Okay, so I want to go through some quick examples of using the different energy equations. So this one says an 875 kilogram car speeds from 22 meters per second to 44 meters per second. What were its initial and final energies? So it's moving, so this means it's kinetic energy. And if you remember, the equation for kinetic energy is 1/2 mv squared. So pretty straightforward. Initial kinetic energy is just going to be 1/2 times the mass of 875 times the velocity, 22 squared. And then the final kinetic energy would be 1/2, same mass, times 44 squared. So I would encourage you, pause the video, actually calculate these out to see what these values are. And you should get that for the initial, it's 211,750 joules. And then for the final, I got 847,000 joules. Okay, so it's a lot. Joules tend to be big, especially when you have big cars moving pretty quickly. Now, I want you to, just to satisfy my need of, I want you to do this, take this 847,000 value and divide it by this 211,750 value. Okay, so divide it and see what you get. Take a moment. You should have found that the kinetic energy final is actually 4 times the kinetic energy initial, and that is not a coincidence. Look what happened to your speed. Your speed went from 22 to 44. Your speed actually doubled. So if the speed doubles, the kinetic energy quadruples, and that's due to the nature of this equation. So it's saying, like, if my speed were to double, so instead of having v, I had 2v, then this mathematically becomes like 1/2 m, and 2 squared is 4, and then v, trying to keep my colors. So 2 squared is 4, and then v squared is v squared. And so you could actually bring out that 4 in front of the entire thing. And so here you have your original equation, okay? So oftentimes in physics, especially like multiple choice type problems, you'll see a scenario where it says, well, what happens if the mass doubles, or the velocity doubles, or the velocity triples? And so you can just kind of manipulate and say, this is the factor that is changing, how does that play out in my equation? And then you bring that factor in front. So if the velocity were to triple, then you would know that the energy would become 9 times as big. If the velocity were to become half, then you know that the kinetic energy would be 1/4 as much, okay? So that's just a little conceptual understanding of how to manipulate the equation. So let's look at another example. This one says, a slinky is stretched a distance of 3 meters. If the amount of energy in the slinky is 310 joules, what is the spring constant? So recall that spring energy, US, so spring energy is equal to 1/2 kx squared, where k is the spring constant and x is the distance stretched or compressed. So pretty straightforward in this case. This is my x value, and this is my spring energy value. So when I go to plug in my values of US is equal to 1/2 kx squared, I've got 310 is equal to 1/2 k times my 3 meters. And again, you're going to be good students. You're going to pause the video. You're going to crunch this out on your handy dandy calculator and get a k value in newtons per meter. And hopefully you get 68.89 newtons per meter. Sometimes I think I should give wrong answers to see if you guys actually check it, but maybe another time. Okay, let's just try one more, this time with gravitation, with gravitational potential energy. And if you recall, our equation for gravitational potential energy, UG is equal to mgh, h being the relative height of an object. So this one says, if you lift a 2 kilogram textbook from the floor to a shelf 2.1 meters above the floor, so here you are, awesome stick figure drawing with you and your huge arms. I think you have to have bigger arms than that. This is totally not the scale. There's the shelf. So this is 2.1 meters above. It says, what is the potential energy relative to the floor? So in this case, pretty straightforward. My mgh is my equation. So my mass is 2. Good old gravity is 9.8. Relative to the floor, that height is 2.1. Pause the video. 2 times 9.8 times 2.1 equals 41.16 joules. And then the second part says relative to your head if you're 1.65 meters tall. So if your height is 1.65 meters, relative to your head is just this little portion. So in this case, when you go to calculate the potential energy, you'd say 2.1 minus 1.65. Again, you're going to be a good student. Pause the video, calculate that out, see what you get. I got 8.82 joules. Okay, so those are examples of, just pretty simple examples of calculating energy for different scenarios.